So if I see this wire in this question, this will create a magnetic field all over this. But let us take at a distance x, let us take a very, very thin rectangle of thickness dx. And this will have some small magnetic flux given by B into area is L dx. Yes or no? This small flux will be given by B into L dx. Correct? And total flux phi B will be given by integral. L will be outside. Magnetic field will be mu naught I over 2 pi x and dx. And flux will be from R to R plus W. So if this rectangle is at the lowest side, it is at distance R. If it is at the uppermost side, it is at distance R plus W. So this is the magnetic flux. First of all, understand this. This is basic calculus. Okay, that is why we learn calculus, because if things are variable, we have to take a small part, calculate quantity for that, and then integrate it throughout. So this will become L mu naught I upon 2 pi ln R plus W upon R. And if I want EMF for this one loop, then it will be L mu naught I by 2 pi 1 upon R plus W upon R, or I can write it in a better way. 1 plus W by R, and derivative of this will be 0 minus W by R square. So it will be EMF is equal to L into dr by dt. We are taking derivative with respect to time. So into R dot. Into R dot. So it will be L mu naught I by 2 pi R by omega plus R minus omega by R square into V. 1 R and 1 R cancel. And just we have to write magnitude. So it will be mu naught L I omega V upon 2 pi R into R plus omega. So which option is correct? So this is EMF and current is E by R. So one more resistance term will be added. So you can correlate, it is option C. A good question, basic use of calculus.